We will now compute the derivative of the natural log of x, which is the only function left whose derivative we need to compute. To do this, we will use the chain rule. If we have the composition of two functions, g circle h of x, or g of h of x, then we can compute the derivative dg dx as the derivative of g with respect to h times the derivative of h with respect to x. We will also use the fact that e to the ln of x equals x and compute the derivative of each side. The right-hand side is rather easy. The derivative of x with respect to x is just 1. However, to compute the left-hand side, the derivative of e to the ln of x, we need to use the chain rule, where our inside function is the ln of x, and our outside function, g of h, is e to the h. In order to use the chain rule, we will need to compute the derivative of g with respect to h, which is e to the h, and the derivative of h with respect to x, which is the derivative of the natural log of x. But this is what we're looking for, so we can't compute that yet. However, using the chain rule, we have that the derivative of e to the ln of x with respect to x is e to the h times the derivative with respect to x of the natural log of x. Then we replace e to the h with e to the natural log of x. But e to the natural log of x is just x. Putting all of this information together, we have that 1 is the derivative of x with respect to x. But the derivative of x with respect to x equals the derivative of e to the ln of x, which we just computed as x times the derivative of the natural log of x. If we cut out the middle of this equality, we have that 1 equals x times the derivative of the natural log of x. Since we want to know the derivative of the natural log of x, we need to solve for it by dividing by x to get that the derivative of the natural log of x is 1 over x. Again, we have just found that the derivative of the natural log of x is 1 over x. Let's use our newfound information that the derivative of the natural log of x is 1 over x to compute an example. Let's look at the function f of x equals 3 plus 2x minus 5x squared plus 4 times the natural log of x. The derivative of f with respect to x is 0, which is the derivative of 3, plus 2, which is the derivative of 2x, minus 10x, which is the derivative of negative 5x squared, plus 4 times 1 over x, which is the derivative of 4 times the natural log of x. So we get that the derivative of f with respect to x is 2 minus 10x plus 4 over x. Now let's look at another example. Let's look at f of x equals the natural log of x plus x squared. Here, to find the derivative of f with respect to x, we need to write the natural log of x plus x squared as a composition of functions. Our inside function here, which we've been writing as h of x, is x plus x squared. And our outside function, g of h, is the natural log of h. Using this composition, we can write f of x as g of h of x. Now, to compute the derivative of f, we need to use the chain rule in finding the derivative of our inside function and the derivative of our outside function. We can find the derivative of our inside function h using the power rule to get dh dx is 1 plus 2x. And using what we just learned is that the derivative of our function ln of h is 1 over h, which we can rewrite as 1 over x plus x squared, since h equals x plus x squared. Putting this together, we get that the derivative of f with respect to x is the derivative of g with respect to h times the derivative of h with respect to x, which is 1 over x plus x squared times 1 plus 2x, which we can rewrite as 1 plus 2x all over x plus x squared. Let's revisit our last example, but replacing x plus x squared with the generic function h of x. Now, in computing the derivative of f with respect to x, we must simply leave our inside function as h of x, but our outside function, g of h, is still the natural log of h, as it was in the last example. Now that we have our composition, f of x equals g of h of x, we can compute the derivative of f using the chain rule again. Now, as we did before, we have that the derivative of g with respect to h is 1 over h. However, the derivative of h with respect to x we can't compute since we don't know h, so we simply must leave it as h prime of x. Putting together the derivative of f with respect to x now, we have that it is the derivative of g with respect to h times the derivative of h with respect to x, which is 1 over h times h prime of x, or rewriting it, h prime of x divided by h. This will be a useful shortcut when we want to compute the derivative of the natural log of some function h of x, which is the derivative with respect to x of the natural log of h of x equals h prime of x over h. Hopefully, this looks familiar. H prime of x over h we've seen before, and we called it the relative rate of change of h of x.